Okay, in the previous lesson, we have learned about factor operations such as factor addition, factor subtraction, and factor multiplication with scalar. Okay, so now I want to add some more factor operations such as cross product, dot product, or scalar multiplication, and factor projection. Okay, let's see, the first one is dot product or scalar multiplication of two factors. Okay, this one is kind of different than the one that we had previously. The one that we had previously is a multiplication of a factor with scalar. Okay, a factor with a number. Well, this one is a multiplication of two factors that produce a scalar number. Okay, the one that we call dot product. Okay, let's just say that I have two factor A and factor B. Well, theta is the angle between A and B. So what is the dot product of these two factors? It's described as this one. Okay, A dot B equals to the magnitude of factor A multiplied by the magnitude of factor B times cosine theta. While theta is the smallest angle between factor A and factor B. So we can say that theta lies between 0 and 180 degrees. Okay, now from this formula, we can see that the result of a dot product is a scalar or a number. Okay, and if theta is equal to 90 degrees or A perpendicular to B, so we get that A dot B equals 0. Why? Because cosine 90 degrees is 0. So we may conclude that factors A and B is perpendicular if and only if A dot B equals to 0, where factor A and factor B is not a 0 factor. And it also applies vice versa. If we say that A dot B equals to 0, then A is perpendicular to B. Okay, to find a dot product of two factors, there are other ways than using the formula in the previous slide. Okay, let's just say that I have factor A, whose component is A1, A2, and A3 in the I, J, and K direction. Factor B, its component is B1, B2, and B3 in I, J, K direction. So the dot product of these two factors, A dot B, is just you multiply the scalar number of each component. For the example, I multiply with I, A1 times B1 plus A2 multiplied by B2 and A3 multiplied by B3. So there you go. You have a dot product of two factors by multiplying the corresponding component. I with I, J with J, K with K. Okay, for example, if I have factor U, 2i minus j plus 2k, and factor v equals 4i plus 10j minus 8k, then the dot product of these two factors is 2 times 4 plus negative 1 times 10 plus 2 times negative 8. And then you add all of these numbers. 8 minus 10 minus 16 equals negative 18. This is the result of dot product of factor U and factor V. Okay, let's see some of the properties of dot product. The first one, Dot product applies in a commutative law. Okay, A dot B equals to B dot A. The second one is distributive law. Okay, A dot in parentheses B plus C is equal to A dot B plus A dot C. Okay, we can expand the form into like this and using the same formula. Okay, this is the commutative law and distributive law in a dot product. Okay, the third one is if a factor multiply by itself, so the answer is the magnitude of the factor itself square. So A dot A equals to A square. Okay. The fourth one is a dot product in a basis factor. I dot I equals to I dot K equals to J dot K equals to 0. Because I, J, K is perpendicular to each other. So if the factor is different, the answer is 0. On the other hand, if the factor is the same, I dot I, J dot J, and K dot K, the dot product of that is equal to 1. Okay, because its magnitude is 1. Okay, these are the properties of dot product. Okay, the angle between two factors. Let's just say that I have two factors, factor A and factor B, and the angle in between A and B is theta. So using the formula of a dot product, this one, the one that we had earlier, from this formula we can see that cos theta is equal to A dot B divided by magnitude of A multiplied by magnitude of B. So this is the formula to find the angle in between two factors. Okay, a projection factor can be described in these two pictures. Okay, the first picture is the projection factor of A onto B. Okay, let's just say that I have factor A and factor B with the angle in between is theta. Okay, factor A is projected onto factor B. As the way to do it is like this. Let's imagine that we make a line from the head of factor A, and we make a line that perpendicular to factor B. So we get factor C. We get factor C as projection factor of A onto B with that has the same direction as factor B. Okay, this is a projection factor of A onto B. Okay, a projection factor of B onto A is similar. We make a line perpendicular from the head of factor B onto factor A. So the projection factor is factor C. That has the same direction as factor A. Okay, this is the description of projection factor. Okay, so now let's see the scalar projection. Okay, what does it mean, the scalar projection? Or some may say the magnitude of projection factor. So scalar projection and the magnitude of projection factor is the same. So scalar means that the result is a number. Okay, and the magnitude means the number will always be positive. Okay, scalar projection or the magnitude of projection factor. Okay, let's just say that I have factor A and factor B. Okay, here I have factor A and factor B. Well, the angle in between A and B is theta. And here, factor C is the projection factor of A onto B. Okay, this is factor C is the projection factor of A onto B. Okay, so here we have a right triangle OAC. Okay, so we have right triangle OAC, and from the trigonometric ratio that we have learned in the previous chapter, we know that cosine theta is the length of C divided by the length of A. Or we can also say that the length of C is equal to the length of A cosine theta. Now, from the previous lesson about the angle between two factors, we have this formula. Okay, cosine theta is equal to A dot B divided by the length of A times the length of B. Okay, so if I replace or substitute the cosine theta in this formula, we have this. Okay, the length of C is equal to the length of A times A dot B divided by the length of A times the length of B. So if we simplify this form, we get the length of C is A dot B divided by the length of B. So this is the scalar projection or the magnitude of projection factor of A onto B. Okay, so the scalar projection of factor A onto B is this. Okay, this is the formula for scalar projection of A onto B. If we want to find the scalar projection of B onto A, we just replace the denominator with the length of A. Okay, so this is the scalar projection or the magnitude of projection factor. Okay, orthogonal projection factor. Now, in the previous slide, we learned how to find the length of projection factor. Here, we will learn how to find the factor itself, the projection factor. Okay, so let's just say that I have factor A and factor B here. This is factor A, this is factor B, while factor C here is the projection factor of factor A on to B. Okay, the C here is the projection factor of factor A on to B. Okay, now from the previous lesson about unit factor, we learned that a factor is equal to the length of its factor multiplied by its unit factor. So here factor C is equal to the length of factor C multiplied by the unit factor C. Okay, from the previous slide, we have the formula for the length of factor C, which is A dot B divided by the length of B. Okay, so this is this from the previous slide. Okay, so, and this unit factor C, as you can see, factor C has the same direction as factor B. Okay, so the unit factor of C will be the same as factor B. So unit factor of C is equal to 1 over the length of B multiplied by factor B. Okay, this is the unit factor C. So if I replace the factor C, we have this. Vector C is A dot B divided by the length of B times 1 over B times vector B. Or we can simplify this form into this. So this is the projection vector of A onto B. So to summarize, the orthogonal projection vector A onto B is this. Okay, you notice the difference between the orthogonal projection vector to scalar projection is the denominator. Okay, this one, denominator is the length of B square, and you multiply by the vector B because the projection vector has the same direction as vector B. And the same way, if you want to find the orthogonal projection vector of B onto A, you just replace the denominator with the length of A square times vector A. Okay, so this is the orthogonal projection vector of A onto B. Okay, now here I have some examples about dot product and a projection vector. So I want you to do this question, but you don't have to submit in Scholar. And tomorrow I will provide you with the answer key so you can check whether you do it correctly or not. Okay, I think that's it for today. Goodbye.